So once again, welcome back from the spring break. And you guys had a great time?
I enjoyed it.
Did you guys go somewhere?
I went to Catalina.
I'm sorry?
I went to Catalina.
Oh, you went to Catalina. It's open there?
Yeah, it's open.
Oh, did you stay overnight?
Oh, I stayed overnight in the condos they have over there.
Oh, good, good, very
That was-
good.
Yeah, that was really fun.
Oh, good. How long did you stay there?
For like 3 days.
Oh, 3 days. That was a good. That sounds like a good 3 days.
Yeah, it was pretty fun. I
That's
gotta relax. What about you? Did you do anything fun?
I actually didn't do anything like that, but I did some gardening. Thank you for asking. And I certainly didn't go to Catalina. I have seasick. So
Oh, you have seasickness?
I have seasickness. If I go, it's because my family is going, so I will go with them. I won't go by myself. And so we stayed in town. And yeah.
You haven't tried the pills?
Yeah, we're working on income tax and all of that stuff.
Oh.
Yeah.
I took care of that before. I took care of that like in I think February.
Oh, good.
W2.
Good for you.
Yeah.
All right. Okay, welcome back, everybody. Did you miss the school? Did you guys miss school?
I'm just not used to it. It was hard to wake up today.
Okay. Actually, I also did some other schoolwork, like, not teaching, but observing other people's classes and stuff at the end of the week before spring break. So I did some paperwork and stuff. But anyway, welcome back. And as I said, we're going to recap on basic 1, and we're going to start a new section, which is a logarithm. Before we move forward, do you guys have any questions? Okay, so regarding recap of basic 1, right? We have 22 basic functions, right? And we have getting more and more familiar with them, and we have actually covered all of them. Okay, but now we're going to take a closer look of operations that's related to exponential and logarithm. Okay, so in particular, okay, we revisit number 9 through number 14. I had some questions on the midterm exam about them, didn't I? Yeah? Okay, so what about them? Domain range. Yeah? And we're gonna get started on log 1. Log 1. Okay, so log 1. Did you find that page? Log 1. So number 9, right? Let's recap on these questions, right? We have number 9, that was, what was it? 2 to the power x? Yeah. Okay, and remember all of these other concepts we have learned, right? Function, of course, first is mathematical principles and functions, one-to-one functions, and so on and so forth, right? Even function, odd function, and all those concepts. Function is a rule, and all of those stuff, right? So number 9 is about this function. We call it 2 to the power x, right? 2 to the power x. Number 10, log base 2x. Number 11, e to the power x. Number 12, ln x. Okay, and more. Ten to the power x. This is the one that we didn't actually graph, but it's very similar, very similar. Okay, so we study about their domain. Insert column. Domain. Range. Intercept. X-intercept. Y-intercept. Okay. So now, so these are the things we're going to recap. Okay, feel free to look at your notes. Feel free to look at your notes. Okay, look at those pictures. Look at those pictures. Do we know them? Do we know them? So how does that picture look like? How does that picture look like? Huh? We did all those plottings, right? We did all of those plottings. I wish I can go back there to grab those pictures, You can, right? Okay. 2 to the power of 1 x. That is a function, and we plotted points. So that's one picture. How about log base 2x? Didn't we do that picture as well? Look at that. Look at your notes. How does that picture look like? Right? Remember we did all of these before? We did 2 to the power x, right? This is related to 2 to the power x. Yeah? We did all of that. Right? All those points we plotted. That's what we mean. Go back there to look at those. And we also plotted e to the power x, didn't we? Right? We did the table. That's 23rd. Let's look at 24. E to the power x. We have all those discussions about domain and range, didn't we? Right? We have all those discussions about domain and range. So are you guys there? Did you guys, can you find the notes? You should know where you wrote it down, right? Okay. With all that said and done, when I meant review, that's what I meant. Okay, and what is E? Okay, and what is E? Right, so this is 2 to the power x. Okay, this is just to review these, okay? If you don't remember, you probably should do it all over again. You probably should do all over again, okay? I probably should adjust these points, but you can still see those points, right? Okay, so now, what is a domain? 2 to the power x. Your contribution on chat. We have done them, right? We plot points. We plotted points, right? We plotted points.
Domain for 2x is called negative infinity to positive infinity.
That's right, from negative infinity to positive infinity. Very good. Go, keep going.
And then for log 2x, it's what's it called? Parentheses 0 and then to infinity. For what's it called? Log 2x.
Log 2x. Just use that.
Yeah. And then and the range for what's it called? 2x is what's it called? It was basically 0 to what's it called? Parentheses 0 to infinity.
You mean which one? This one?
No, 2x.
2x. What's the range?
0 to what's it called? Infinity.
0 to infinity. Okay. Very good. Larger than 0. Yeah. And what's the range?
And that one's negative infinity to positive infinity.
Okay. E to the power x. Domain and range. It's all in the picture, right?
Yep.
I want you to look at those notes because we did all those points. We have all those reflections at the time. This is not about memorization, guys. This is not about memorization. Okay, I want you to remember, I want you to recall all those things we did. Thank you for your contribution, Mikhail and Cortland. Keep going. E to the power x ln x. What's the domain range for each one of them? We did a 2 to the power x, we did a log base 2x, right? And we did all real numbers, very good. How about range for Very good, excellent, right? E to the power x is larger than 0, right? use these, okay? Use these, okay? You guys, do you hear me? I don't care about that interval stuff. How about the domain and range for ln x?
It's the same thing as log 2x.
That's right. Right? How about 10x then? All right. Have you done the 10x yourself? You should have. You should have. Okay. All right. So let's look at intercepts. Okay. The curve right in front of you. Let's look at the intercepts. Let's look at the intercepts. Intercept. What? I couldn't hear. Can you put it on chat? On chat. Hold on. Let's see what you mean there. Ah, I made a mess there. What did I do there? It's so ugly. Huh. Sorry about that, but you know what I meant, right? I hope you have the right picture. So I probably just reproduce one. Okay. So the second picture is about e to the power x and ln x. Okay, the second picture is about ranges all real numbers. Okay, very good. We're talking about intercepts. So ugly. Could you contribute on intercept? -1. All right, so I think I'm going to do something else. Okay, I'm going to the y-intercept for, very good, Cortland. Did you guys see what's the comments of Cortland? There's no x-intercept on all the exponential functions, but y-intercept is 0, 1. Very good. Very good. We're talking about the basic functions, okay? The basic exponential functions. All right. So next, what I like to do is that I'm going to do this. Okay, I'm going to delete all of them. No. Well, cancel. Okay. Okay, I have cleaned this up. What I like you guys to do with me is to mark these points. Okay, this is the curve 2 to the power x, and this is log base 2x. Okay, let's see if you still know how to mark those points. The y-intercept, that's the y-intercept, right? This is 2 to the power x. And that point, this point, is the y-intercept. 0, 1. Can you mark all these other points? Look at the tables we made. Look at the tables we made, right? So this point is 1, 2. When input is 1, output is 2. Input is 2, output is what? 4. And this point input -1, output half. And this one point over here, what is that point?
-2 1/4.
That's right, -2, 1/4. So that's for the function 2 to the power x, right? Remember all those points we plotted. Now, let's look at the other curve. Okay, this curve is log base 2x. So now I want you to mark each one of these 5 points, 1, 2, 3, 4, 5. And for 2 to the power x, there's no x-intercept, right? There's no x-intercept. Very good comments, okay? Very good comments on chat. Does everybody follow? Does everybody follow? Am I going too slow? Okay, so the x-intercept for log base 2x is 1, 0. And this point is what? What is this point? What's the input? 1/2, -1. Different function, different rule. And this other point, 1/4. Remember, the input can only be positive number. And that point, I'm sorry?
I'm just saying it.
2, 1, right? And this point is 4, 2. Yeah. Now, your turn to mark all these red points on this picture. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 10 points. Please mark them. Did you finish? Anybody want to send a picture up, upload a picture? No? Okay, so we know how to mark those points, don't we? So I have marked these points. Hopefully this will confirm your marking. Okay, so let's look at this point. Okay, this point, which is 2e squared, right? Yes? Yeah? This point is 2e squared. How about this one? Negative 1 e to the power negative 1. And that point, negative 2 e to the power negative 2, or 1 over e squared. Okay? Now, these points on natural log ln x, okay, on ln x, ln x, okay? Now, what is this point? This point. Look at the table, right? It should be e squared, comma, 2. Okay? And this point is e to the power negative 1, comma, negative 1. Last but not least, this point is e to the power of negative 2, comma, negative 2. All right? And we're not done yet. We're not done yet. Now, look at the other way of writing them. Look at the other way of writing them, right? So we have all of these, right? This is 2 to the power x, e to the power x. And you can certainly do 10 to the power x log x, right? Common log x. Now, take for example, okay? For all of these notations, it's pretty easy to understand, right? Take the exponential part is easy to understand. The exponential part is easy to understand. Yeah? Do you agree? Yeah. You see, you can see they're inverse function to each other, and when x equals to negative 2, for e2 to the power x, the output is 1/4, right? Now let's look at the other side. Let's look at the other side, okay? And this point, we're going to reflect on the definition. We're going to reflect on the definition of logarithm, okay? The definition of logarithm. So we're going to do one at a time. I'm going to clean all of these up on the screen, so you need to have them down on your notes. Do you have them down on your notes? Do you? Okay. So I'm going to clean up now. Yes? Are you ready? Okay. Now, so let's look at the definition. We understand the picture, right? We understand the picture, right? Oh, let's fill these up. Let's fill these up, okay? Let's fill these up real quick. X-intercept for 2 to the power x, none, right? X-intercept here is 1, 0. And the rest is the same, right? Y-intercept?
0, 1.
0, 1.
Then
And this one?
none. None.
Yeah? Agree?
Agreed.
Okay. Any question? No. Okay. So let's look at the notation wise, right? We know this is 2 to the power x, right? So let's look at the intercepts. when we are working with this rule, two to the power x, okay? We started a little slow, okay? But we're getting there. Input is 0. Output is what? Output is 1, right? And there's another machine. There's another rule, okay, which is a log base 2x. Okay, log base 2x. When the input is 1, output is 0. Yeah? So let me do this so we can better organize this process. Okay. 2 columns. We only need 2 columns. Okay. So here's the rule. And here's the other rule. Okay. This is a 2 to the power x. And this is log base 2x. Right? So these are the 2 rules. Okay. And we're going to introduce the notation, which is log base 2. When the input is 1, output is 0. Follow me? And this part is all easy. This part is all easy. In fact, the definition between these two is marked by, okay, is marked by, so now let's look at the definition. Okay, let's look at the definition. Insert column. Okay, definition. Okay. Two to the power of x equals to omega if and only if log base 2 omega equals to, so I'm going to put this as a triangle, okay? I'm just trying to use some different notation so it doesn't get messed up. Okay, so this is the definition. Okay, this is the definition when base 2 is considered. Okay, so now if you understand this process, right, and you have marked all of these points, right? We have marked all of these points, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. I just used this point, 1, 0, right? And next, we want you to be familiar with the notation. Okay, log base 2, 2. What does that equal to? Log base 2, 4. What does that equal to? Log base 2 half. Log base 2 quarter. Log base 2 1/16. Can you fill in these numbers? Some are in the table, most of them in the table we did before. And the last one is a little bit new. And I can keep the list going on.
First one's 1.
I'm sorry, this one?
Yeah. 1, 2, and then -1, -2, then -3. And then is it -1 again?
This is -3.
Yeah, that one's -3.
This
The
one's
-4, my
-3.
bad, -4, my bad, -4.
Mm-hmm.
And that one's -1, right?
No,
No, it's
you can use definition. You can use a graph. You can use the inverse function. So all these tools you can use.
was the 1/2.
That's right. It's 1/2. The next one. We're working on the same picture, don't we?
Oh, that one's 1/3.
That's right. Why is that? If you apply the definition, right? If you apply the definition, right? In order to identify, this is easy, right? But don't forget where it came from. Okay, this is basically saying, well, log base. We apply the same definition. Okay, so log base 2 right here. Okay, this is log base 2 1. So when this is 1, this is 0, right? Because 2 to the power of 0 is 1, right? Now, when this is 1, log base 2 is 1, so this is 2. The place that number at omega is what? Is 2. This is 1. Yeah? Yes? Now it's 2, log base 2, 4 equals to 2, because 2 to the power 2 is 4. Does everybody follow? Do I need to go over this? Because I just don't want anybody to be left out. Okay, so when this case, omega is 1/2, and this is what? -1, because 2 to the power -1 is what? Is half. You see that? Now, keep going. What have we found? When this is the case, okay, because 2 to the power -2 is 1/4. Follow? Now, how about this one? this is in the place of omega. 2 to the power of -4 is 1/16. Any questions so far? Now, for that one, how did it go? Log base 2 root 2. Root 2 is 2 to the power of half. Okay, 2 to the power of half is what? What is 2 to the power of half? It's root 2, isn't it? Does everybody follow? Yeah? And the same reason for all of that. Yeah? Did we find a pattern? Did we find some kind of pattern here? Yeah? Cubic root of 2 is 2 to the power of what? 1/3. And 2 to the power 1/3 is a cubic root of 2. Yes? Did you find the pattern? Watch this. Watch this. Log base 2 log base 2 of 1. This 1 is 2 to the power 0. So log base 2 of 1 log is the same as log base 2 of 2 to the power 0. So the answer is 0. And that's 2 to the power of 1. And that's 2 to the power 2. Did you see a pattern? Did you see a pattern? Watch closely. This is 2 to the power of 2 to the power of -2. Yeah, do you guys see the pattern? Did you see the pattern? Can you complete this pattern? So if you can write it as a base 2, you can write it as a base 2, right? Could you complete that pattern? So what pattern did you see? What pattern did you see? Now the question is, all of these numbers I have chosen, they can easily be written as 2 to certain power, right? If these two bases are the same, then we get the answer easy, yeah? But what if it's not? Can I do this to any number? Can I do this to any number? Right, so let me give you another number. Can you write 5 in the power with the power of 2? The answer is yes, we can. The secret is in the definition. The secret is in the definition. So here's the definition, okay? Watch this. Watch this. Okay? Log base 2, 5. Suppose this is equal to the triangle. Right? This is the triangle. Okay? Now, this is 5. The question is what number we can put here, right? What number should we put here? Triangle. And this is certainly 5. Yeah? You follow me? Oops, sorry. Now, the triangle is the whole of that. So if I copy this and put it right here, it should equal to 5. It's like a game, isn't it? It's like a game, isn't it? Yes? So can you write 5 with base 2 in the exponential function? Yes, you can do this with every positive number. Okay? In fact, this is equals to log base 2. 5 is the same as this guy. Okay? So that is equals to, it's still just log base 2, 5. We go around a circle, but we introduce something like this. This tells us for any positive number, you can express it in exponential form with any base. Not only with base 2, it can also be with base 5, base 10, base 3, base e. Okay, what we need to be familiar with all of these. All of these. Okay, so now I want you to look at the table log 2. The table called log 2 in your notes. I have assigned homework to you before. Now I just want you guys to see those in a different light. You encounter different bases, don't you? The ideas are all the same, just different rules, different log base. Do you follow me? If you haven't done that, or you haven't finished log 2, you haven't finished log 1, which I assigned you before, you must do it now. Okay? Now, so when you get into your future classes, right, calculus class, for example, you might be given something like this. You work a problem, right, in your calculus class. Okay, you work a question. Okay, that question is pretty long. You go through some steps. Okay, in the last step, you encountered this in the last step, ln E. What does that equal to? In your calculus class, you're not going to see log base 2 very much. You're not going to see common log very much. You're going to see ln, e to the power x ln, most of the time. Okay, so we're going to work. Okay, we're going to work at this part. We're going to work the second table. Any questions so far? Okay, so let's work on the second picture, and it's the interpretation. Okay, so this is the question, right? Whether you have the answer or not, we'll come back. Okay, we'll come back. This piece is e to the power x. That's not a problem, right? E to the power -2, e to the power, all of that stuff. We did those tables, right? So please have the notes we did before on basic 1 next to you. Okay, this is not a test. This is making connections. Okay, so we're going to work out a similar table. Okay, we're going to work out a similar table. Okay, I do copy and paste. I want to show you that they are similar. It's just a different base. E to the power x ln. Okay, this is ln E, and so this is E, and this is ln. Everything stay the same. Everything stay the same. Okay, so I'm going to clean all of these up. You can see the basic principles and basic relationship are the same. Yeah? So far, so good? All right. Let's look at the ln's in the picture. These points we just marked, right? You guys have those marked points, right? You have those tables we worked before, didn't you? Do you have those in front of you? Well, next. All you need is practice and getting familiar and practice. Okay, a lot of our students cannot answer these basic questions. These are considered very basic questions. You can see how they're derived from the picture, right? Why it's important to mark those points. Right? ln E. is referring to
1.
these 2 points. You
The
see
first
that?
one. Yep.
That's right.
And then
It's
next one.
equals to 1.
And then next one 2. And then I'm guessing negative.
And the next one, what is the point it refers to?
That one. What do you mean? Oh, that one refers to 2.
Right?
Yeah.
And that's the
next one's
point it
negative
refers
2.
to.
Yeah.
And that's the point it refers to. For 2 to the power x, it has the same relationship.
Oh, that's
Okay.
really easy.
I'm sorry?
No, that's just really easy.
It's really easy, right? But we need to get familiar with the notation. Once you get familiar with notation, yes, it should be easy. Okay, it should be easy for you. I'm so glad to hear that word. Now, the answer here is what?
The negative 1.
That's right. Now, back to the question we had earlier. ln root e, what does that equal to? What does that equal to? What is ln square root of e? What does that equal to?
1/2.
That's right. Is it easy? Yeah? So when you work those steps in your calculus class, it may be calculus 1 or calculus 2. In the final steps, you came up to this. You know what the answer, don't you? What is the answer? You should know immediately, in a fraction of a second, confidently write down that answer. Okay? Do you follow me? So all of these exercises I have done, we have worked together since the beginning, right? And what does this equal to?
Would it be 1/3?
That's right. Why is a question? You should be answering that question with confidence. It must be 1/3. If anybody has a different answer, you're going to argue with him or her till the end of the world. Yeah. Yes, you should have that kind of confidence. And you're certain you're going to win. Okay, even though this is not about winning or losing, but it's about building confidence. Okay. All right. So did you guys get the reason? Do you want me to go over these reasonings? Can you feel that? Can you feel that out? Do you see the connection? Don't you? Do you see the connection? Yes? Do you see the connections? Right? They're all because this definition, even these two definitions can be condensed into one. Okay? What I meant is this definition about logarithm. And this other definition about logarithm with a special E, these two definitions can be combined into one. Of course, you have many more. You can have many more, right? You could have 10, right? This could be 10. That would be common log. And that could be, say this can be 3, right? You see those kind of exercise in log 2, don't you? Yes? And these can be 7. You could have a 7 here. Do you see those? Yeah? And all of these can be condensed into one, which is base B raised to the power triangle equals to omega if and only if log base B omega equals to triangle. So this is the ultimate summary of the logarithm definition. Of course, we need to specify the B, right? We need to specify the B. This B is E, this B is 7, this B is 3, this B is 10, this B is 2. B must be greater than 0, but it cannot equals to 1. So this is the final definition. Sometimes it's written in a reverse order. Okay, sometimes the right and left are switched place. The left and right switch places. Do you guys see that? Is that going to affect you? Is that going to affect you how you work these questions? Of course not. Left is right, right is left. It doesn't matter, right? Okay, so that should wrap up the log 1 and log 2, which I assigned to you before. And I didn't check on you very intensively. But now you should be able to do them all. If you haven't done them, great. If you have done them before and you got stuck somewhere, so work on them. Okay, let's look at log 3. Any questions so far? So let's look at log 3. Log 3 is based on either one, okay? So it doesn't matter which one we use it, right? It's a general statement. But this general statement, you have a glimpse of it when we were doing when we were doing this. Okay, do you guys see that? And then you wonder, is that true for ln? Do we have something similar? i.e., if I make this E and this ln, is that true?
Yes.
Yes. Okay. And you guys are going to use this in calculus. Okay. In calculus, you're going to see this. Okay, this is going to be exactly what you're going to see. Even the symbols are the same in chapter 3 or chapter 4, depending on the order. Now your question is, if we have this, right? And we also have, where's my ln? and we have this. Do I have similar things on common law? How about this? What do you say? Yes or no? The answer is yes. What does this tell you? What does this tell you? It's a very interesting phenomenon. Okay, I'm going to elaborate this. I'm going to elaborate this because you're going to use this in calculus class. Okay, you're going to use exactly this one, this guy. So in order to explain the significance of this expression, okay, this expression come from, just play with this definition. Okay, so let me show you how we get this expression. Playing with this definition, what do we call playing with it? Okay, play with that. Okay, and we take this with us. Okay, and in this relationship, they're bounded in this relationship. So the triangle is the same as this guy. So I simply replace the triangle by its equal. Replace this triangle by its equal. So this is true. The key in this expression is that this exponential base is b, and the logarithm base in the exponents part is also b. So when these two b's are the same, which are greater than 0, not equals to 1, and this is always true. This telling us this is always true. And what's the significance of it? What's the significance? The significance of it, first of all, you see that omega is always positive, right? Because it's in the domain. You follow me? Omega is always positive. Yes, because it is in the domain of logarithm, right? If this is always a positive, meaning it can be any positive number. And this any positive number, okay, this any positive number can be expressed in an exponential form. This any positive number can be expressed in exponential form of any base larger than 0, not equals to 1. Like that. Can we have a narrative for it? Any positive number, omega, can be expressed in an exponential form. With base b That's the significance. Okay, for example, 5 can be expressed 5 can be expressed. Any positive number, 5 is a positive number, can be expressed in an exponential form with any base. If I choose base 2, and that can be done. If I choose base E, that can be done. If I choose base 10, that can be done. If I choose base 7, that can be done. Do you guys understand? So when you see a mathematical expression, right? When you see a mathematical expression, you want to make sense out of it, right? You can see this result is trivial from that play, right? We just play with the symbols randomly, don't we? We just play with the symbols randomly. It was fun, right? And we got something totally significant. Okay, and in calculus class, what's being used is any positive number will be expressed then you say, what's the point of doing that? Right? I'm sure you're thinking about, well, why? Isn't this expression simpler? Why you want to make it more complicated? Well, you will find out by the time you get there. Okay, you will find out by the time you get there. Okay, so the entirety of log 3 is about that. Is about applying this identity. Okay, it's about applying this identity. So far, so good? Do you think you can handle them? Okay. Next, we're going to work on 2 important logarithm rules. Okay. Oftentimes, we saw these mistakes. I already tell you these are mistakes. What are these mistakes? In calculus class, we often see these. Do you agree these are mistakes? How many of you think these are mistakes? I told you they are mistakes. They're not just any mistake. They're terrible mistakes. But these mistakes seem to be so intuitive, isn't it? Right? Do you think you might be making these mistakes? It seems so natural, right? Of course, it should be that way. No, it's not. Okay, so the following exercise, log 4, log 5, is addressing to these mistakes. Why are these mistakes? Because they're not true. You can find counterexamples for each one of them. You can find counterexamples for each one of them easily. Okay, why? All right. Still from the definition. Okay, still from the definition. I want you guys to take out your paper, pencil, and derive with me. Okay. This is a relationship. This is the relationship, okay? So please take your paper, pencil, to derive with me. Okay, we're working entirely from this expression. Okay, we know this relationship, right? This is the basic relationship. So we're gonna use this relationship. So now suppose I have b to the power m. So this is gonna be m, right? Yes, I'm gonna call this omega for m. Yeah. On the same relationship, and this is gonna be n. So this is omega sub n. Omega sub n. And this is n. Yes? You guys follow me? Okay, now I'm going to multiply these two. What do I get? What do I get?
BMN.
I should get b to the power of what?
MN.
Mn? Like this? Is that what you meant?
Yeah.
Does everybody agree with that?
Yes.
Everybody agrees with it. Go to basic 21 and come back. Go to basic 21. These are the exercises I have assigned you before. Basic 21. Go back to basic 21. Look at those exercises. B to the power 3 multiply b to the power 2. What does that equal to? It's BBB times BB. What does that equal to? Huh? What does that equal to? It's b to the power 5, isn't it? So b to the power 3 multiply b to the power 2 equals to what? Equals to b to the power of what? 3 plus 2, isn't it? So is that right?
Oh no, it'd be plus.
That's right.
It'd be m plus b.
How could we
I mean
make
m
these
plus
kind of
n.
mistakes? I'm stunned. I appreciate the interaction. So please do basic 21, okay? Please do basic 21. These are the assignments I have given you before. Plus, when do you multiply? When do you have m times n? We're going to be using this later, very soon. Huh? Is b to the power of m and then to the power of n, or b to the power of n, and then to the power of m. Yes?
Yep.
Why is that?
Because you're multiplying the exponents with the m.
Why you multiply? Good answer. Do you simply just go by memorization? That's not the
No.
way to learn. If you look at b raised to the power of 5 and then raised to the power of 3, what do?
You multiply the exponents.
Sure, you're right. This is what's going on, isn't it?
Yep.
You take here to the power of 3. So this is going to be what? B raised to the power
15.
of what? 5
15.
plus 5 plus 5. That's a b raised to the power of
15.
5 times 3. I want you guys to know these basics, guys. You don't need to memorize. I'm not asking you to memorize it. Okay? Got it? So when you get stuck, you need to know what to think. Basic definition, which start from 2 to the power of 5 is the same as 2 times 2 times 2 times 2 times 2, 5 times from here, from this basic definition that we got. And the 2 turn into what? It's from here. Are you guys with me? Tell me if my explanation here is redundant. All is from here. All of these are from here. Okay? All right. Coming back. So I'm going to put this for note. Okay? Let's come back to this basic deriving. Why these are mistakes? Why these are mistakes? All right? Is everybody following me? Okay.
Yes.
So b to the power m plus n, and that should equals to something what? B to the power m times b to the power n. And there should be an omega here. Okay, and this will lead to, in the logarithm form, what would that be? Log base b omega. What is omega? Omega is right here, right? Equals to what? M plus n. Yeah? Yes? And what is omega? Omega is b to the power m plus n, and this is omega m. Yes? Because b to the power m is what? Is this guy. Yeah? Let me write it down. Is omega m multiply omega n. Agree? Yes? Because these two are the same, right? Yeah? Now, log base b omega, omega is the product. Yes? Now, I'm going to take this final version. Do you guys see me? I'm taking that final version here. that omega is omega m sub omega sub m times omega sub n. Okay, let me just put this in parentheses, even though it's not necessary. And equals to m plus n. Okay? Now, what is m? What is m? What is m? M is this guy. What is n? N is this guy. So omega, so in the end, what do we get?
That guy plus that guy
Yep.
equals log, what's it called? Log B omega. There you go.
Yep. So comparing to one of the mistakes. Is that a mistake? If you've gone through this deriving with me, which you should do 5 times after class, you will never make these kind of mistakes. But these mistakes are very common. These mistakes are very common. I see it every year. Every semester I teach a calculus. If I teach a calculus class, I always see these mistakes. Okay? So this is x, this is y, right? So this is the x, and this is a y.
The
Does
difference
that see
is here.
better? Do you see better
Yeah.
now?
Yeah,
Do you see that's a mistake?
Yep.
And you should be able to find a counter example for it. Okay? All right, so we have some interesting discussions, and I really, really appreciate the interaction. But from these interactions, I can recommend the exercise for you. Okay, so please, homework. Basic 21 again. Okay, if you haven't done it, well, you did it before, you forgot, do it again. Basic 21. (22A). Okay. All the way. 23 all the way to, I'm not going to give you too much. 21, 22A, log 1, log 2, log 3, log 4 today. And we'll continue on this tomorrow, okay? But meanwhile, I want you guys to try this, okay? Go through these process 5 times by yourself until you can do this independently by yourself. And then try this. Dividing. Okay? To see what you discover. Could you please do that? Okay, after you derive what we did today. Okay. And discover for yourself. All right. So that's all for today. And I'll see you guys tomorrow.
All right, see you
Very good
tomorrow.
job. Very good contribution. Very good discussion. Forgive my response. Okay, my response was very but it's not personal. It's not personal. Okay, there's no personal personal anything involved. Okay, it's just we all need to refresh, we need to recap, we need to redo the, practice. But I promise you 10 years from now you don't have to do this. Okay, you will have get your degree and you settle in your beautiful career and life is good. Okay, see you guys tomorrow.
Thank you.
Thank you.
Have a good one, Professor.
You have a great day. Thank you. Good job.